Hello, I am Dr. John Eric Steephen of the School of Digital Sciences, Digital University, Kerala. My talk is about emotions and machines, two terms that we don't usually expect to go together except perhaps in movies. However, in today's world, it's increasingly becoming evident that their possible association cannot be ignored. This talk will have some general information as well as the findings from our own research. In the last decade or so, many of us know that there has been a lot of advancement in the area of artificial intelligence. Machines are becoming increasingly intelligent, and as a consequence, they are approaching human beings in intelligent decision making and judgments. However, one aspect continues to distinguish man from machine, and that is that humans are emotional beings whereas machines are not. In human beings, our decisions and judgments are greatly influenced by our emotions. It is believed that emotions are used as information while we form our judgments and take decisions. This raises an interesting question. If machines need to make judgments and take decisions like human beings, do they also have to have emotions? That raises another question. Is it even possible to impart emotions in machines? To understand that, we need to look at emotions a little bit more closer. Emotions are thought to have at least three different manifestations: the behavioral aspect, the physiological aspect, and the phenomenological aspect. The behavioral aspect is when we tend to behave in certain ways depending on the type of emotion that we experience. For example, we lash out at someone when we are angry, we cry when we are sad, or we laugh when we are happy. Also, there are changes in our facial expressions and body language depending on the type of emotion that we are experiencing. Then we have the physiological aspect that refers to the changes in the body caused by our hormones and the autonomic nervous system. This includes changes to the blood pressure, heart rate, changes in the level of sweating and pupil size change, etc. For example, when somebody is afraid, his BP increases, his heart rate increases, the pupils dilate and he sweat more. Then we have the third aspect, which is the phenomenological aspect. This refers to the actual feeling of emotion. For example, when we say that I am feeling sad or I am feeling happy, we are referring to the phenomenological aspect. The behavioral aspect can be fairly easily observed. The physiological aspect can be measured with various instruments, but the phenomenological aspect can be experienced and felt only by the person experiencing it. So, it is something which cannot be measured or observed by others. Further, emotions are usually either pleasant or unpleasant. For example, happiness is a pleasant emotion, sadness, anger, fear, etc. are unpleasant emotions. A pleasant emotion is a positive experienced state that we try to seek, enhance and maintain, whereas an unpleasant emotion is a negative experienced state that we try to avoid, minimize and eliminate. Now, when talking about emotions, there are two other very closely related terms, which are mood and affect. There are subtle differences between these. When we say emotion, we generally refer to an intense short-term feeling. Mood is long-term and is milder, and affect refers to both emotion and mood. In this presentation, I do not make a distinction between these three terms, and they are used interchangeably, more or less to mean the general affect. Okay, I had mentioned earlier that emotions influence our decision making. Let's look at a scenario. It's called the trolley problem. Some of you may be already aware of it. Consider a train going down a track, and the track is bifurcating into two. In one of the bifurcated tracks, 5 people are working, and in the other, 1 person is working. If nothing is done, the train is going to go through the track with 5 people and kill all of them. But you have a choice. There is a lever beside you which, if you shift, can move the train to the other track, killing one person and saving the 5 others. The question is whether you will do it or not. When this question is posed to people, most people will say that yes, they'll do it, they'll save the 5 people at the cost of 1. That's a fairly rational decision, and if we provide all the information to a machine will also make the same decision. Now let us look at another scenario. Again, the train is going through the track and 5 people are working on the track. In between the train and the 5 people, there is a bridge on which you are standing. Beside you, there is a huge fat man standing with you. If nothing is done, the train is going to run over the 5 people, killing all of them. But again, you have a choice. You push this man down and he falls on the track. The train will come and hit him and will kill him, but it will stop there and save the 5 people. Again, the question is whether you will do it or not. When this question is asked to people, most people will say that no, they won't do it. They will not push down that man and kill him for saving 5 other people on the track. This may not really be a very rational decision, and a machine most likely will decide to push the man down to save the 5 people at the cost of 1. So you see that there is a difference in the kind of decision making that a machine would do and a human would do. And most likely this is because humans use emotion also as information in their decision making process. Now let us look at judgments. It is generally believed that your mood will determine your judgments also. So this is called the mood congruency effect. Now, as an example, if you are looking back at some events which has happened in the past, if you are in a good mood, you tend to remember them as more pleasant than if you are in a bad mood. However, this relation between your judgments and your experienced emotion may not be so straightforward. One of the important abilities that humans have is the ability to recognize other people's emotions. It's a very important ability which has been shown to influence one's career and work. Now, this judgment could also be influenced by one's own emotion. To study this, we conducted a study. In this study, we got a set of participants. We divided them into 2 groups. We made one group happy by showing them a happy video, and we made the other group sad by showing them a sad video. It is shown in the figure here on the top left. Initially, you can see that the 2 groups had a fairly same emotional state. The blue line corresponds to the group of people who were shown the happy video, and the red line corresponds to the group of people who were shown the sad video. At point T3, when the videos have already been shown, you can see from the graph that the people who watched the happy video were happy and those who watched the sad video were sad, as indicated by the rise in the blue line and the fall in the red line. Later, at time T4, the emotion decreased, but that's not our concern here. Immediately after making them happy and sad, we showed them facial expressions depicting various emotions as shown in the picture on the right side. Here we have shown just 2 examples, but we showed several faces to these people and asked them to estimate the emotion that they are viewing on these faces. 2 interesting observations we found from the study. It was observed that while one's mood influenced greatly their perception of the happiness emotion, it did not quite influence the perception of the sadness emotion, as shown by the graph at the bottom left. You can see a great change happening to the blue line, whereas the red line remaining fairly constant. A second observation was that this influence of mood on judgment differed between male participants and female participants. The males were more affected or more influenced by their mood than females, as shown by these lines on the right side at the bottom, The red line corresponds to females. It's fairly horizontal, indicating that they were not much affected, but is more slanting for males, which showed that they were influenced by their mood when they judged the faces. So, it is not only clear that emotions do affect one's judgment, but also that it is not very simple and straightforward, and it is rather complicated and influenced by the type of emotion and gender and often other factors. So, if we need to include machines with emotions, then we need to take care of all these things. And let me ask the question which I asked in the beginning: should machines be emotionally intelligent like humans? Yes, they need to, if they have to interpret human emotions, empathize with humans, interact effectively with humans, understand our thinking and decision making, predict human actions which are the result of our decisions, again influenced by emotions, and finally, if we want them to make judgments and take decisions like humans. Now, when we talk about emotions in machines, there are three aspects to it. One is emotion expression, the second is emotion recognition, and third, the feeling of emotion. Emotion expression is fairly easy as far as machines are concerned. You can have humanoid robots expressing happiness or sadness, just like the image shown here of Sophia, the famous robot. Also, we have virtual characters expressing emotions. Even a smiley is an expression of an emotion by a virtual character. So, that is not a very challenging thing. But when we come to recognizing emotions, it is more challenging. Emotion recognition is not just identifying what emotion a person is experiencing, but rather estimating the intensity and quality of emotion and how it is varying over time. We recognize emotion usually from the behavioral aspect, that is the body language and facial expression, and we estimate the phenomenological aspect, that is from the expression we estimate the experience of emotion the other person is feeling. So, it is only an estimate. The relation between the expressed emotion and experienced emotion is also not so straightforward. It is influenced by various factors such as the emotion type and gender. This makes accurate emotion estimation difficult. However, as humans, we have evolved methods to apply corrections wherever required so that we can estimate one's experienced emotion as accurate as possible. Let me demonstrate this with another experiment that we conducted. We took a set of faces expressing emotions, added long hair to them and labeled them as females. We took the same set of faces without any change, replaced the long hair with short hair and labeled them as males. Then we showed these two sets to a group of participants and asked them who is happier and who is less happy. And the result was that the male faces, or the faces which the participants thought belonged to males, were told to be happier as compared to the faces which the participants thought were females. In fact, all the faces were same. The faces that were shown as male faces and the faces that were shown as female faces were exactly the same. Just to demonstrate this further, look at this figure on the top left. You can see two faces, one with short hair and designated as a male and the other with long hair designated as female. When this was shown to the participants, they said that the left face is happier. Then the gender was reversed for these two faces as shown in the figure at the top right. Only the gender was changed. The faces were identical. Now, when the participants were asked the same question, they said the right face looks happier. So, just by knowing the gender of a person, one's perception of their happiness has changed. This is because of certain perceptual correction that we apply to compensate for the enhanced expressive cues of happiness by females. When the same study was done for sad faces, as shown in the pictures below, there was no such difference, which means that no perceptual correction was applied for sad faces since it is not required. So even the perceptual correction that is applied that is based on gender depends on the type of emotion. Currently, machines don't take care of any of these things when they try to recognize emotions, and we need them to take care of this if we expect them to accurately estimate the emotion of other people. Now we come to the third aspect, and probably the most complicated. Can we make machines feel emotions? Well, there's a short and long answer to it. The short answer is that no. Only conscious beings can feel emotions, and machines are not conscious beings, at least not yet. But there is an alternative. We can use computational models of emotions to simulate the effect of feeling of emotion and can use that to influence judgments and decision making in machines. Computational models of emotion have got many applications. They can provide us a greater understanding of the human emotion system. That knowledge in turn can be used in computing. They can also be used by medical health professionals to predict the emotion trajectory of patients who have disorders associated with emotions. And they can also be used in affectively intelligent systems as the emotion brain of machines. Several models of emotions have been proposed till date. For example, we have the EMA model of Marsala and Grach, the AIR model of Bossels and Beliza, and our own model series called the HEAD model series. HEAD stands for Human Emotion Dynamics. Different modeling efforts have taken different approaches towards modeling emotions, but I'll be talking a little more about our own modeling approach. For that, we need to look at emotions in a slightly different perspective. This is what I would like to call the emotion life cycle. Normally, an emotional event happens and you experience an emotion, but it's not always all that simple. If you know of an emotional event that is going to happen later, you may start feeling the emotion right away. For example, when you know that 2 days later you're going to have a birthday party, you'll start feeling happiness probably now itself. And then you'll feel the happiness through the party, and even after the party is over, 2 weeks from now, when you look back at this, when you remember that party, again you feel happy. Okay? So you have an anticipation phase, you have a reaction phase, and you also have a memory phase. Most of the events are often predicted in advance, at least to some extent, and so the emotion experienced will span all these three phases. But it's not always the case. If you have something happening by surprise, there won't be an anticipation phase. In addition to these three phases, we can also think of an imagination phase where we just imagine things and then we feel a certain emotion. For example, a child may feel happy thinking that he or she is a superhero. Let us look at the reaction phase a little bit more closely. The reaction phase has at least three different stages. When an event happens, the first thing is we try to understand what the event is, what are its consequences for us, how is it relevant to us, and so on. It is based on this information that we gather our emotion is decided. If it is not self-relevant, we may not have any emotion, but if it is self-relevant, we will experience an emotion. Though the initial emotion may be fairly intense, we will see that this emotion will decrease and disappear over time. Initially, the decrease will be rapid and then it will be relatively slow. This is something which we experience on a daily basis. Imagine that you want to buy something which you really care about, let's say the latest iPhone model. You buy it today, you are very happy. A week from now, you are still happy about it, but not as happy as on the first day. What has happened? You still have the same iPhone with you. Nothing has changed, but only your emotion has reduced. This process is called affective adaptation. Affective adaptation is rapid initially, that is called the rapid initial stage, and then the reduction in emotion slows down in the steady homogeneous stage. Thus, you will see that the quality and intensity of emotion varies over time from the anticipation phase through the different stages of the reaction phase and through the memory phase. This change in the quality and intensity of emotion over all these phases and stages is what is called emotion dynamics. And that is what is the focus of the HEAD series of models. Generally, when you have an event happening in our life, an emotional event, it will result in an emotion. But this resulting emotion is also influenced by a lot of factors. One of them I just mentioned, that is affective adaptation, but that's not the only factor. There are other factors such as sensitization, desensitization, time to the event, anticipation, fatigue, and so on. So the resulting emotion dynamics is the net result of the characteristics of the event which caused the emotion, as well as all these factors acting on the emotion. So the overall objective of the HEAD series of models is to explore, explain, and simulate the interplay of the various characteristics of the emotion eliciting event, as well as the various factors that influence emotion dynamics. So this led to our first model in the series called HEAD 1.0 or just HEAD. The objective was to see how affective adaptation influences emotion dynamics. This model was based on the adaptation level theory of Helson in 1964. We also had to do quantitative representation of emotions and emotional events since it's a computational model. The model was built using a set of first order differential equations. The model successfully captured all the features of affective adaptation, and not only that, it reproduced several different emotional phenomena that was reported across literature over the last few decades successfully. Then we moved on to the next model in the series, a more advanced model called HEAD 2 or HEAD ID. Normally, whenever we talk about emotions, we talk about its intensity. We say, I am feeling very happy, or I am feeling a little sad, and so on. We rarely speak about the duration of emotion. How long is that emotion going to last? So the duration of an emotion is as pertinent an aspect of emotion as is its intensity. Then another question arises, how does the intensity relate to its duration? Generally, we may think that the stronger the emotion, the longer it is going to last. And it is true in many cases, but not always. There are situations when stronger emotions die down faster than the weaker emotions. One interesting study that was done just after the 9/11 attacks in the US showed that people who were affected more recovered faster than people who were affected less. This phenomenon is referred to the region beta paradox. So this results in an interesting question, how does intensity and duration relate to each other? Something which we'd like to call the intensity duration problem of emotion. So that was what the new model, that is the HEAD 2 model, hoped to address. The HEAD 2 model did not have sufficient data that was required. There was some information available from the literature, but that was not enough. So initially we conducted an experimental study to collect some data that we needed for the model. We also used data from literature. We also based on our earlier model, and we also used an earlier model by Wilson and Gilbert called the area model. Combining the information from all these, combining the elements of all these, we built the HEAD 2 model. The HEAD 2 model offered a plausible solution to the intensity duration problem of emotion, and its results were consistent with empirical findings related to intensity and duration across literature. Currently, we are working on another model, a more advanced model called HEAD 3 or HEAD ARM, which is hoped to study the influence of changes in emotional events, reappraisals, anticipations, and multiple events on the overall emotion dynamics. Emotion events often change over time, and the resulting emotions also correspondingly change. Some events, when it happens, we perceive them as good events and we feel happy, but maybe on further analysis you realize that no, that was not something which I wanted to happen. So on reappraisals, our perception of events and the resulting emotions change. Also, in real world, emotional events don't always happen in a sequence. Sometimes multiple events happen together. So all this influence our emotion dynamics, and the net emotion dynamics is a result of various such factors and various changing scenarios. So the objective of the Head 3 model, which we are currently working on, is to see how these different factors influence and shape emotion dynamics. Other models, more advanced models, are also planned, which will look at other factors that influence emotions. The final objective is to come up with a comprehensive model of emotion dynamics that can be used as the emotional brain in various artificial systems. Now, before I conclude, let me give an example of a research study that was conducted at our university. It's an example of an emotionally intelligent surveillance system, an affectively intelligent system that uses an emotion model for decision and judgment. Now, suppose when you do surveillance of a crowded area, you see people standing close to each other. They could either be fighting, as shown in the figure on the left side, or they could be hugging, as shown in the image on the right side. As a human, we may be able to know what they are doing, but as a machine, they may not be able to recognize exactly whether they are fighting or hugging from the images available. One way to resolve this problem is to use an emotion model. We can try to recognize the crowd emotion, pass it on to an emotion model that will tell us whether the crowd is actually fighting or they are hugging. So if they are fighting, we may need to call the police, and if they are hugging, we don't need to do anything. So that is one application which I would like to present of the use of an emotion model in an emotionally intelligent surveillance system. So before I end my presentation, let me just say that the use of emotions and emotion models are going to increase in the near future and in the future machines that are being developed. Thank you.